Start.
To pick people.
I'll be the guinea pig. So is everybody ready? Yeah, okay, great. So, good afternoon, I guess, at this point. I'm very glad to see you, albeit I'm disappointed that we're not meeting in person. As I said, it was the highlight of my month. It used to be before we quarantined ourselves. So the thing is, when you announced this topic, the world ocean, I spent a lot of time thinking about the topic. And then about 3 days ago, it occurred to me that I should have talked about pirates. I thought it was so cool, and I couldn't understand how come, like all good ideas, this one came too late. I had already announced my topic. I had already posted the glossary and prepared my presentation. So no pirates for you guys this time. I will have to talk about tides, and maybe next time I will talk about pirates. Okay, so I decided to talk about tides. We all know sort of what they are. So when we hear the word tides, we kind of have a picture in our mind. A picture that looks somewhat like that. So on the left, this is low tide. So we think about those terms, low tide and high tide. So low tide, that's when we have a portion of the seafloor exposed. And then during high tide, the water, the sea level rises and the water covers the portion of the ocean floor. So that's how we picture tides, and this is very familiar. So the difference between the high and the low points are called tidal range. And the surface of the seafloor that is exposed or covered by water, depending on whether we're at a low tide or at a high tide, is called intertidal zone. Okay, so tidal changes actually proceed in 4 stages, and the water is never static. So at any given point in time, the water is either receding or rising. So the tidal changes proceed in 4 stages. First, sea level rises over several hours, and that's what we call flood tide. Then the sea level reaches its highest point, and this is what we call high tide. Then after that, the sea level begins to fall, and it takes several hours. This is what we call ebb tide. And then finally, the sea level reaches its lowest point, and this is what we call a low tide. And then the process begins all over again. Tides vary in terms of their tidal range. For example, in the Canadian Bay of Fundy, the tidal range is up to 50 feet or 15 meters. This means that up to 50 feet of the ocean floor is exposed during a low tide. In contrast, in the Caribbean and the Mediterranean regions, the tidal ranges are much smaller. So what is so interesting about tides? Well, first of all, tides are determined by extraterrestrial bodies or events, as you probably know. So we typically associate tides with the moon, or phases of the moon. Tides also illustrate how the gravitational and the centrifugal force work. On such a global, universal scale. You can demonstrate it in a glass of water, but this is truly magnificent. Tides are also important for all sorts of human activities, such as navigation, fishing, or power generation. And tides are also essential for survival of many marine species. So tides play an important role in the Earth ecosystem, including humans. Now, before we go into this whole mechanism behind how tides are formed, let's do some trivia. So those things are presumably known to everybody, but I find that for myself, they do not exactly roll off my tongue. So I had to refresh my knowledge on how this whole sun, moon, earth system works. So the Earth goes around the sun. We all know that, presumably. We've just had a brief discussion about how the Earth might be flat after all, but for the purposes of this presentation, let's say that it is round. And it takes a year for the Earth to orbit the sun, 365 days, 5 hours, 48 minutes, and 46 seconds. So the Earth rotates on its axis as well. So while it's going around the sun, it also rotates on its own axis, and it takes it 24 hours. So this is our Earth day. And finally, the moon orbits the Earth, and it takes the moon, after all said and done, 29.5 days. So it's there are some bells and whistles that I'm not going to go into, so we'll just settle on 29.5 days for our purposes. Now, the moon also rotates on its own axis, and it takes the moon about the same time as it takes it to orbit the Earth. So you see there is a lot of rotation going on, and with all of this rotation, different sides of the Earth face the moon and the sun at different times, and that affects the frequency of tides, the tidal range, and their features in general. Okay, so this is a bit of trivia. So now the moon orbits the Earth rotates on its axis, and with the moon going around it, it also orbits the sun. So as I said, different sides are exposed. Now, in addition to this rotational arrangement, there are also two forces at play here, the gravitational force and the centrifugal force. So the sun and the moon both exert gravitational force on the Earth. So the gravitational force, I'm sure you know what it is, but it's basically, it's the attraction, right? So the gravitational force of the moon pulls the Earth and everything on Earth towards itself. You also might remember that the gravitational force depends on the mass. So the bigger the mass, the larger the force. So the moon is smaller than the sun, but because it's much closer to the Earth, its gravitational pull is actually stronger than the gravitational pull of the sun. So this is the gravitational force. In addition to the gravitational force, the rotation of the Earth produces the centrifugal force. So the centrifugal force pushes everything on Earth away from its axis. So the centrifugal force you experience when, for example, you're in a car and this car drives along a curve on the road, especially a steep curve. So you can feel that as you turn the curve, you're being pulled away from the car center towards the door. So if your car did not have doors, you would have fallen out of the car because the mass of the car is not enough to pull you back towards the center. So the same thing happens on Earth. So when the Earth rotates on its axis, it creates the centrifugal force that pushes everything away from its axis. But the gravitational force of the Earth counteracts the centrifugal force. So that's how everything remains on Earth. Otherwise, we would have just all fallen off. Okay, so we have the rotation of different celestial bodies, the three bodies in particular, and we have the gravitational force and the centrifugal force. And that's what determines our tides. So basically what happens, the gravitational and the centrifugal force make the water in the ocean bulge. So as the moon moves around the Earth, it pulls the water towards it, creating a bulge. At the same time, as the Earth rotates on its axis, the centrifugal force pushes the water away from its axis and also creates a bulge. But the gravitational force pulls everything towards the axis, the center of the Earth. Now, the moon's gravitational attraction is weaker on the side of the Earth that faces away from the moon at that particular moment. Okay. So this is as far as the gravitational force and the centrifugal force are concerned. There are other factors that influence the particular features of tides in a particular location. They influence the specific range, frequency, and timing. And this information needs to be taken into account if we want to predict tides. So one of those factors is bathymetry, for example. This is the features of the ocean floor, its relief, varying depth in different locations, etc. The amphidromic system, that's another factor that's important. The amphidromic system is a particular wave pattern that's characteristic of a particular location in the ocean. So all of this information has to be taken into account to compile tide tables or tide charts, which I will talk about in a bit. Okay, so another factor that I forgot to mention, the shape of the coastline. That too affects what kind of tide this or one or another location is going to have. Okay, so as a result of all those factors, tides vary in terms of tidal range. As I said, the difference between the lowest and the highest point. And they also vary in terms of their frequency. So in terms of variation in tidal range, we have spring tides and neap tides. So spring tides happen twice a month around new moon and full moon. So at that time, the moon and the sun are aligned relative to the earth. Astronomers refer to this alignment as syzygy. It comes from the Greek word syzygy, I believe I pronounce it right, which means union. The tidal force due to the sun reinforces the tidal force due to the moon. And in addition, the centrifugal force due to the Earth's rotation contributes to the tidal bulge as it pushes the water away from the axis. So as a result, a bigger bulge in the ocean is created, which means a larger tide. So the tidal range, meaning the difference between the high tide and the low tide, is then at its maximum. So the name of this tidal range does not come from the season, by the way, but it has the same etymology as the word for season, spring. It means jump or rise or break forth. So here is the picture. That's what the alignment looks like. So we see that the sun, the moon, and the earth in this picture are aligned in a straight line. And so the gravitational force from the sun reinforces the gravitational force due to the moon. Okay, so, and this happens every 2 weeks. Okay, the next one is neap tides. So neap tides also happen about twice a month. And at this point, the sun and the moon are separated by 90 degrees relative to the earth. So they're pulling in the opposite direction, and the tidal force due to the sun partially cancels the tidal force due to the moon. Since the gravitational force is weaker, the water in the ocean is not pulled as hard towards the moon. The bulge is smaller accordingly, so the tidal range is at its minimum. The word for neap, the word neap actually means one without power. And so here I have the diagram to show, sorry. Yeah. So you can see that the sun and the moon are located at 90 degrees and they're not pulling along a straight line. They're sort of pulling not exactly in the opposite direction, but they're pulling at an angle relative to each other. So that's why the gravitational pull of the moon is partially canceled by the gravitational pull of the sun. Okay, so you can see that, as we said, the moon month is about 28 days or 29 days, so it's 4 weeks. So first we have new moon, and that's when we have the highest tide, the highest tidal range. After 7 days, we have a neap tide, when the sun and the moon are arranged at 90 degrees. And then after 7 days, we have full moon. And during full moon, again, we have a spring tide, which is the maximal tidal range. And then again, 7 days later, we're back to neap tide. And then the cycle starts all over again. Okay, so tides also differ with respect to their frequency. We can have diurnal, semi-diurnal, or mixed tides. So a diurnal tide is when you have one high and one low tide per day. Semi-diurnal when you have two high and two low per day. And then finally mixed tides when we have two tides of uneven range per day. And what it means is that, for example, when you have an even tide, diurnal even tide, so for instance, your tidal range is 40 feet, let's suppose, pretty high. So when during low tide, 40 feet of the ocean floor is exposed. So when you have a high tide, then 40 feet of the ocean floor are covered by the water. When you have a mixed tide, you can have, for example, 40 feet of the ocean floor exposed during the low tide, but then when the sea level rises, it only covers up to 20 feet. So this is called mixed tides. Okay. So history has been pretty interesting, and the people have been studying tides for thousands of years because tides are very important for sailors. It was important for people to be able to explain and to predict tidal occurrences. The study of tides is called tidal physics. And the first data go back to 4th century BC that we have. It was a Greek geographer named Pytheas, who is believed to be first to have connected tides to the phases of the moon. Then a Babylonian astronomer by the name was Seleucus. I'm not sure that that's how it's pronounced, but that's the guy. So a Babylonian astronomer in the 2nd century BC proposed a theory. He said that tides were due to the moon. And he was the first to notice that the tidal range depends on the moon's position relative to the sun. Other famous physicists who were interested in tidal occurrences and made their contribution to the development of the tidal theory include Galileo Galilei, Isaac Newton, and Johannes Kepler. The question is, why are we so interested in tides, and why is it important to predict them? As I said, tides affect life on Earth, as well as many human activities such as fishing or navigation. Oceans have approximately 2 tidal shifts per day. So there are 2 high and 2 low tides every day. So they would be semi-diurnal would be the most common pattern. Sea creatures that live on or near the shore depend on the changing tide for their survival. Many different species of fish and other animals move according to the changing tide. And so being able to predict the tidal cycle is vital for fishing communities around the world. Tidal occurrences are also very important for navigation. For centuries, sailors had to study the tide changes. During a low tide, ships may get stranded on the shore for several hours or even days. And if the ship is on schedule and it has to leave the port, then the sailors must haul it to deeper waters so that it can set sail. The construction of docks and ports is also affected by the tidal changes, as well as decisions what docks should be used and when. Which brings me to tide tables or tide charts, that people started constructing them as soon as they became aware of tides and as soon as they realized that tides can actually be predicted. But in the modern day, there are organizations that post annual tide charts or tide tables. They include, for example, the International Hydrographic Organization or the National Ocean Service in the USA. So coming towards the end, what I actually wanted to do, and I hope it will work, but I actually wanted to show you how it works. So I'll try and take you to the website of the National Ocean Service and see if it will work. So my link is actually clickable. So if you bear with me, we'll see what happens. So I'll just tell you, if it doesn't work, I'll just tell you what I was going to show you. It's actually pretty cool. You can go to their website and you can click on different locations, and there is a tide chart for every location in the United States showing you the tidal range, the frequency, and the tidal cycle. So it takes, can you see my screen? Can you see the, okay. So it's just a matter of time, and I promise you it won't take, I'm at the end of my presentation, so it may be like an extra minute. Looks pretty cool. Okay, so we're here. Can you see this? Yeah, okay, great. So you can see that this is California. I just picked that randomly. You can go to Alaska, Alabama, Louisiana, anywhere. So let's say we have this location. We want to know what the tides in this location look like in San Carlos. So we click on it and we wait for another 5 years. It's coming up. I won't do another one, so I'll just, I'm actually very impressed with my old laptop that I can pull it off. Okay, here, can you see the chart? Yeah, okay, so this is the chart for this particular location, and the chart is for 2 days. So if you scroll down, you can see all the necessary data. So this covers March 28th and March 29th. So this chart is compiled for 2 days. So you can see here on the left, height in feet. This is our tidal range. So the height of the high tide and the height of the low tide. So if you look at this chart, you can say that here we have a mixed tide pattern, because the high here at 12 a.m. is different from the high at 12 p.m. of the same day. It's not as high. And the low tide at 6 a.m. is lower than the low at 6 p.m. So here this is half a foot, and at 6 p.m. is 1.5 feet. And then we see that it fluctuates further. So this is a very kind of neat website. So you can, and presumably you can go, if you Google, you can see, you can find such tide charts for other locations internationally as well. So this has been my presentation. Thank you very much. Oh, I can even get back and see if I can. Oh, there you go. No, it doesn't want to do this. It doesn't want to cooperate. Okay, well, anyway, it was the last slide that said thank you. I think I won't torture my laptop anymore. Thank you.